today I want to talk to you about a very common algebra mistake. This is an algebra mistake that could derail a problem for you and cost you a lot of points potentially on a quiz or exam. Okay, so I am going to write an expression on the board here, and we're going to talk about the correct way to work with this expression. Alright, so what I want to look at is x plus 2 quantity squared. Okay, so first I'm going to show you what the mistake is. So what you might mistakenly simplify this to is x squared plus 2 squared, or in other words, x squared plus 4. But that's not the correct way to evaluate this expression. So this is bad. And let me try to prove to you why that is. So let's say instead of x plus 2 quantity squared, let's just use some numbers in here. And let's say we had 3 plus 2 quantity squared. So using the same logic I showed above here, if I use that same line of thought, this would equal 3 squared plus 2 squared, or 9 plus 4, which is 13. Okay, so this is my proposal. But what if I actually use order of operations here to evaluate this? Well, I would get 5 squared, which is 25, not 13. Okay, so once again, this method of thinking is incorrect. So what is the correct way to evaluate this expression? So if I have x plus 2 quantity squared, and I need to expand this, then the way I must approach this is by foiling. So x plus 2 squared means x plus 2 times x plus 2, and then from there I would FOIL. So x squared plus 2x plus 2x plus 4, or if I combine terms, x squared plus 4x plus 4. This would be the correct expansion of my expression. Okay, so now we've talked about how to correctly expand this. Let me show you something that is a little bit different but along the same lines, right? Something related algebraically. Okay, I want to now look at this expression, 2x quantity squared. So in this scenario, what I'm going to do to expand this is I am going to square each factor of this product. So this is going to become 4x squared. Okay, so I'm just kind of showing this to you so you can kind of compare and contrast, right, these two expressions here. And the one on my left here that I'm underlining in green, what I have here is I have a product of multiple factors, right? This is 2 times x, and that product is being squared. And when I have a product that is being squared, then each factor of the product gets the square. So this becomes 2 squared, which is 4, times x squared. This would be the same approach if you had 2x cubed, or 2x to the 4th, or 2x to any power. Each factor of the product would get the power. Now that is in opposition to what we just finished discussing, x plus 2 quantity squared. The difference here is that I have a sum, and the sum is being squared. And when a sum is being squared, I cannot simply distribute the square to both terms. I have to, like we just discussed, FOIL this out. X plus 2 times x plus 2. So make sure you distinguish in your minds the difference between these two scenarios and expand accordingly when you see this on a quiz or exam. So next we're going to look at something that is quite similar, but instead of squares, we're going to look at square roots. So let's say I have this expression, and I'm working on a problem, and I get this. So here's the mistake that is made often. The mistake is to think that we can simplify this to x plus 3. Okay, this is bad. This is not correct. All right, we cannot simplify this to x plus 3. So once again, let me give you a concrete example with some numbers to try to prove this to you. So let's say I have the square root of 3 squared plus 4 squared, and I'm wondering what that is. Well, if we use the method I've shown up here in the first line, we might say, well, this equals 3 plus 4, which equals 7. But is that really correct? Let's use order of operations. If I use order of operations, I work underneath the square root first, where I get 9 plus 16, which in turn equals the square root of 25, which in turn equals 5. 5 is the correct answer. 7 is the incorrect answer. Okay, so the point here is that if we have a sum under a square root, we cannot split it up, just like when we had a sum inside a square. So one more point. What if we have 9x squared? So now what I have is I have a product under a square root. And we can actually split this up. Okay, I can say this is the square root of 9 times the square root of x squared. The square root of 9 is 3, so I get 3 times the square root of x squared. And that's actually going to give me 3 times the absolute value of x. So the square root of x squared is actually the absolute value of x. I'm not going to go into detail with that. That's not my point in this little lesson here. My point is that we can split up a product under a square root. And this is in opposition to, for example, the square root of x squared plus 9, which cannot be split up. Alright, so hopefully this little video will give you a chance to review a very important algebra concept and hopefully save you a few points on an upcoming exam.